All right, so we're going to continue where we were from last class. If you weren't here last class, you need to watch last class because we can't recreate the whole 80 minutes of last class. We're going to do a little bit of review, if I get the right pen. Basically, last class we talked about definition of AC and DC power and the fact that AC power is what is best transmitted and what comes from our wall. DC power is what is steady state and most electronic devices use, and this device changes it from AC to DC, and it's a rectifier and a transformer. It rectifies from AC to DC and it transforms it to different powers. And I just said that backwards. It transforms it to AC to DCs and rectifies it to different powers. Okay, the same thing happens with our power supply that's in our computer. It changes it from AC to DC, and then it changes it to the different voltages. And then we talked about the definition of volts, amps, and watts, and I'm going to start there, okay? So we said volts, let me grab a pen. Volts was the potential for electricity to flow through something. And I made the analogy with your water pipes in your home that it's the size of the pipe. There's no water in it, it's just potential, right? It doesn't mean anything's going through it. It gives you the potential for so much water. The voltage rating of an electrical component is how much potential it has to have electricity go through it. The amperage, or the amps, equals the current of the electricity that's going through there. So I equated that to when you turn on your faucet. There's supposed to be a little faucet handle, by the way, outside at your garden, and it comes out of a pipe. How much you open that is equal to the amperage. The amount of current that goes through there, in the case of this, water current, is defined by how big you turn it. In electricity, the total amperage, the amperage that we see, the rated amperage, is the current that's going through that potential circuit. So we end up with watts, which equals, or wattage, either one, which equals total power. Total power, which equals volts times amps, okay? So the amount of power that comes out of something is equal to the potential for that electricity times the current of that electricity, okay? And in the case of this analogy, how big you turn the faucet, along with how big the pipe is, will define how much water can come out. So that's kind of where I made that water analogy. So we got to this. We're going to talk more about this ratio or this equation, because like I said last class, this is really the only section that we do math in the course pretty much. And so we need to understand this equation. Watts equals volts times amps. And we said that power supplies are rated by wattage, okay? How much power can flow through that power supply, which is where our math comes in for this section. How much wattage it can handle determines what kind of components we can put in it, or conversely, the components that we have in our PC determine how much wattage we need in our power supply. We're going to come back to this. I'm just kind of doing a review here. We talked about that, and then we got to static electricity, and we were at static electricity when we stopped. Static electricity is that discharge or equaling of potentials between things. So if I were to touch Jason, there is a static electric discharge that happens between it when we level out our charge, which is why every time I said we get inside a computer, we initially touch the power supply. And we touch the power supply because do this without killing myself. There we go. We touch the power supply because it's the hardiest piece of equipment inside there. It's all metal on the outside. And why did I say it's all metal on the outside? Okay, we ground ourselves because it's all metal, but why is it really all metal?
Because so it won't catch on fire.
Because it won't catch on fire, and I talked about how last class we used all the power supply testers. We pulled the power supplies and we tested them so that you guys know how to test them. And I talked about one of my students was working on a computer. He left the power supply connector on here. He left it plugged in, and he came to find me to tell me that the power supply was bad. And when we returned to the classroom, there was fire inside and smoke billowing out. And if this wasn't metal, that would have caught something else on fire. Okay? So these are metal because they handle the heat. Metal helps dissipate heat, and is the only thing that should catch fire, or hopefully never catches fire. But it's doing a lot inside there when it's transforming that power from AC to DC, and it gets hot. So that's one of the reasons we do that, though, is to dissipate static electricity because it's metal and because it's made to handle those changes in power. So we do this. And then we talked about the 3 levels of static electricity. I'm going to go back to our slide. Voltage to feel it, we said, is how much? 3,000 volts. We have to discharge 3,000 volts before we even know that we discharged anything. Meaning that if we discharge 2,500 volts, if I just touched him and I discharged 2,500 volts, he wouldn't even know. Okay? But it could certainly ruin an electrical component, which is why every time I come up, I grab this first. Okay? Or if that's pulled, I grab the case, because many times the cases are metal, and even if the case isn't metal, I grab a metal part inside the computer. Okay? To try to discharge that. To hear it, it's 6,000 volts. Okay, if you hear that crack when you do it, and to see it, to actually see the little blue that go between us is 8,000 volts. Okay? Guaranteed stomp, stomp, stomp. That'll be on the test with a little matching thing. Okay? And the big thing I want you to get from it is not really that, man, I'm going to try to get 8,000 volts so when I shock my sister I can see it. It's that you don't even know if it's below 3,000. And these are approximations. You may be more sensitive to static electricity than me. Maybe I don't feel it till 4 and you feel it at 1,500. I don't know. How do they come up with this number? They shock a whole bunch of people. Did you feel it? Did you feel? Yeah. I don't know. I don't know how they come up with that number. So anyways, but these are numbers that I want you guys to know. And then we talked about the control devices that are available to us, of which we use none of those. Okay? In my experience, I don't need to if I am careful when I work on stuff. If I push the power button every time before I get inside a computer to dissipate the power that's in there. If I grab the power supply every single time before I get inside a computer, I've equalized myself. But they have grounded bracelets that you can put on. It's a strap that has a wire with an alligator clip that you clip on your PC. They have grounding mats that you can work on. And then every time we get something, it comes in an anti-static bag, like one of these. Even these cables came in anti-static bags, so that when I got them, I didn't dissipate it. How am I going to hurt the cable? I don't know. But anyway, that's what an anti-static bag is for, so that it, along the way between shipping from where it came from and where you got to, really, is so that in shipping, there was no static electricity discharge. And believe me, when that's going down a conveyor at an airport, those things, by the way, are the worst. If you're ever in the back of an airport, they have all these metal roller conveyor things that all the luggage and stuff goes down. I've got the bejesus shocked out of me when I was an airline pilot before, just walking along and I put my hand on it, I'm like, ah! I guarantee you I got that 8,000 plus on that one. There was so much static buildup from those rollers, I don't know. Anyway, I would imagine those would be grounded. Maybe I just got unlucky with that one. But the point of those is really not when it gets here, it's everywhere it goes along the way in that cardboard box before it gets to me, so to make sure it gets here good. Okay? And I've already said this. Touch the computer case power supply before you touch any component. So that's where we stopped last class, and this is where we got to now. So we're talking a little bit more about electricity. When your parents, hopefully, have told you never to stick a fork or anything inside an outlet. But in all reality, only one of those spots is going to hurt you, okay, if your house is wired right. Of the 3, one's going to kill you, and the other 2, you're just going to be like, it didn't do anything, okay? The ground, the big, I'm going to draw, okay, shaped like this, right? That gets broken off of half your things in your house, and maybe you have an old house, your dad's taken a pair of pliers and broken the ground off half the plugs anyway, because my old house, when I moved into it, every plug was a two-prong plug, no ground. It goes to ground. That's what it does. All those wires go into your electrical panel at one spot, and that your electrical box has a wire that runs out to somewhere stuck down in the ground. Okay? That ground is there so that any over voltages go somewhere other than you or your house or whatever else is plugged in. Okay? Without grounds, many electrical things are in danger. Okay? And we're going to talk about things that we have to help protect us from electricity and electricity problems today, and none of them work without a ground. So the church where we go to church, half the outlets are two-prong outlets, and we got all these great surge suppressors, and they do absolutely nothing without a ground. Okay? So the other one, the smaller of these two, if you've got a newer outlet, old outlets, I've lived in almost all antique houses my whole life. To have a three-prong outlet is only there because I rewired. But the little one's the one that's hot. That's where the electricity comes in. And the other one is where electricity goes out, because electrical things work. Here's my little light bulb here for you. Because of the flow of electricity. They come in through the hot and they go out through the neutral. Realistically, if you stick a knife in the neutral, you shouldn't get shocked. Don't do it. I'm not advertising that, okay? Because electricity is flowing all around your house between here and here. But if you were on a circuit where nothing's plugged in at all and you stuck something in there, nothing would happen. Okay? But a lot of times the reason people get electrocuted when they're working on stuff is these things aren't wired like that everywhere. Okay? Realistically, if I came over here and I turned off my light and I went to work on changing the fixture up there, I should not be able to get shocked. Because if it was wired right, I just stopped the electricity right over there. But if you ever do any electrical work, they always say, always turn off the circuit breaker to wherever you're working, because all it takes is one miswire, which I have in my house. I have a cross wire in my house where two breakers, this breaker somewhere in the walls connects with this breaker over here, and I have it labeled on my circuit breaker, turn off this one and that one. Because if I'm working on this breaker and I don't turn off that breaker, I'm going to get shocked. Because I only know that because I have. Okay? It's weird. I don't know how. I think the neutrals are crossed. Because I won't get a full shock. I'll just get a really pleasant buzz. And when I say pleasant, I don't mean pleasant at all. But it's not like I stuck something in there. But it's certainly like somebody came up and hit me with a cattle prod. Low-powered cattle prod. And I'm not happy about it. So, turn off the breaker. Always make sure it works. So, we've got electricity comes in through the hot and theoretically goes out through the neutral. And that's what those difference in plugs are for and why they only go in one way. Okay? The ground is where any over voltages are supposed to go out to. And many of the things that we just talked about for grounding ourselves have plugs that plug into the thing. You know, it'll have a grounding mat, it'll have something like this that plugs in. Really, those two do nothing. They're disconnected. It's just really connecting you to the outside ground, so you're even more grounded than you would be if you just touched this stuff. Okay. So there's our grounding strap. You can see it's connected to the case, but then the case is plugged in. You're like, it's plugged in, but it's not really. This cable only has a grounding wire. Okay, so that this case is grounded with a grounding wire. It's not really plugged in, although it looks like in this picture. And then he's grounded to the case with that grounding strap. So that's what that is. And the same thing applies with one that goes in a grounding mat. On this case, it's connected to the mat. And you can see the little picture with only one plug on that plug-in. It grounds it out there. And I've already shown you anti-static bags. It's really to protect the component more in shipping than anywhere else. Okay, so now we're on to our power supply itself and the things that we have to know about our power supply. We have a number of plugs, and every single time I pick up a power supply, unless it's all out of the same machine that are exactly the same power supply, these ends are going to be slightly different in what I have available to me, okay? So two of them are going to be standard and should be on every single one. And that's the P1 plug and the P4 plug. The P1 plug is this big one, or this big one right here, that connects to the motherboard. And then, this picture doesn't even have it. Hopefully I got a picture here next, yeah, with the P4 plug that also goes to the motherboard. So these are the two motherboard plugs, and you can barely see my writing because I'm using black on black, and that's probably not a good choice. So these two right there go to the motherboard, okay? every power supply you get are going to have a P1 and a P4 because you have to. Now, the P1 plug is either 20, 24, or in most cases 20/24, meaning like this one, it's a 24 pin, it's a 20 pin. See, it just slides on and off, and I showed you that the other day when we were looking at those. Most power supplies anymore are either 24s or 20/24s because most motherboards anymore really are 24 pin P1 plugs. Okay, so while we're talking about, let's see if I have a better picture. Yeah, I do have a better picture. Okay, so here's the 24 pin. It's called a 24 pin ATX because if you had an AT, you wouldn't even have this plug at all because it's a totally different kind of plug. But, so this is a 20, am I still in red? 20/24 is what this one really is because there's the 20 and there's the extra 4. The voltage on this is the lowest voltage of all of them. Okay? Test question. It's 3.3 volts. The P1 plug is 3.3 volts. It's the only one that's 3.3 volts. I guarantee you a matching question on this one. So does that mean the least amount of power goes to the motherboard because it's only 3.3 volts? No, because that is not power. It's potential, right? Just because the voltage is low doesn't mean the wattage is low. It actually means if the watts are high on this motherboard, what does it mean? It means the amps are also high. Okay? Because volts times amps equal power or wattage. Okay? So just because it's the lowest voltage does not mean it uses the least amount of power. In all reality, this and this, right? Where's my other one? There we go. I don't even see it. Oh, it's over here. Okay. All reality, this one, my pen, and this one, those two are powering our motherboard and our CPU. There's probably a lot of wattage going through there. Now this one's 3.3, but the CPU is a power hog. This one is 12 volts. Okay? So that CPU requires more power. It's a 12 volt power plug. Again, that's not a definition of power, that's a definition of potential. Okay? The pipe is small going into the motherboard. That doesn't mean there's not a lot of water flowing through. Okay? So 3.3 volts is P1, and in actuality, all of these are 12, other than that one, and the floppy drive one, which we almost never use. Okay? So for all reality, other than the P1 connector, assume everything else is a 12 volt connector, because we really don't use this one anymore at all. But it's a matching one, so if you see the floppy drive, that's the 5 volt. All of these other ones are 12 volt plugs. Okay? So, this is a video one, by the way. Let's go through these plugs. So I got my motherboard plug here, which is called my P1 plug. These kind of plugs, I'm going to switch colors here. This Molex and this SATA plug right here have the exact same purpose. Okay? These are 12 volt plugs that we plug in the CD-ROMs and into hard drives, and they're exactly the same. And when I say they're exactly the same, that one says 4 pins, one says 15 pins, but they're exactly the same in the fact that if I'm short of one of them, all I have to do is hook up a little adapter, and I can go either way with this. If I hook up this adapter, it turns that one into that one. So if my power supply is short of a connector, I can buy one of these on eBay for 99 cents. If I'm short the other way, this one turns this one into that one. Okay? So all I need is a little tiny adapter, and if I'm putting in a new motherboard and I've got a power supply that still seems to be working fine, but I don't have the right plugs on here, because if I look at this one, I've got 2 of these SATA plugs, but everything else on here is a Molex. I don't need Molexes. That's okay. All I have to do is buy some of these, and it just plugs into the end. If I put it on the right way, plugs into the end, and now I got another SATA connector. Okay, so the voltage coming out of there is exactly the same. I have a bunch of those because I keep using power supplies as long as they're good. As long as the power supply is good, I'm going to keep using it until it proves itself otherwise. So these are 12 volts, and these are the most common ones, the Molex and the SATA. And we're going to learn more about what SATA is really in the next chapter, but this is the most common one now. Didn't used to be, which is why these older ones have only one line of the other one and a ton of these. And this really is less common. Okay? Of the other things on here, very unlikely to see this on anything. It says a Dell P6 plug. Okay? Very unlikely to see this one. Very unlikely to see that one. Those are just a graphic that I found. Okay? But this one's one that you may very much need. Okay, this is different. It says 6-pin PCI Express. PCI Express is video card. A high-end video card might need one of these, might need two of these to power it, depending on the video card. So if you're building a gamer rig and I'm buying a power supply, I need to figure out how much power it needs, how much wattage it needs, and like I said, they're all rated for a certain amount of wattage, and this one's a 350 watt, okay? Above 350, I'm asking for components to fail and or overheat and shut down the power supply itself and burn it up. And when I say burn it up, I mean literally burn it up. That was the only time I've ever had one catch fire when I say that, but it just fries the components inside, it doesn't work anymore. Which is why this is a very common thing to go out. Because not just when you buy a new video card and put it in, do you forget to calculate it, but when you buy this system from Dell and say, I want this hard drive, and I want this CD-ROM, and I want this Blu-ray burner, and I want this sound card, and I want this video card, they very frequently never even change this. And I've changed a lot of people's power supplies that there's no way it should have even worked, in my opinion. Because when I did the calculation, I'm like, you needed a 450, and this is a 300. How the heck did it ever work? Well, it's been acting weird for a long time. Where when many things try to run at the same time, it just won't have the power, so the hard drive just doesn't work. Or I can't use the CD-ROM. I was watching a movie, it doesn't work anymore. Okay? So, I've got this one, I've got this one on all of them. How many of these I have depends on what power supply I buy. Okay? And just because I have a lot of plugs doesn't mean I can use them all. That's part of the definition of the wattage. And then the PCI Express, again, is a 12 volt, and I think I might have one of those in here too. You can buy, oh, what in the world are these in there for? I think I got one in here someplace. There we go. So this one changes it from no, that's not what that one is. I take that one back. Oh, there we go. Okay, so this one takes a single PCI Express and changes it into two PCI Expresses. Okay? Questionable how well that's going to work. But you also have ones that change it from Molex to PCI Express as well. So I've got those cables that I can get to make things work. So voltages, 3.3, 12, 12, 12, 12, 12, 12, 12, and 5. Okay? So when in doubt, it's probably 12 volts other than the I didn't update the slide. We're going to take a break right here and do reading, but I didn't update the slide, so let's go to where I wanted you to do the reading. Sign on. Let's see if actually, I guess I don't want to do it. Let me see what I just did on my thing over there. I should have written it down better. Nope, okay. So what I want you guys to do, we're going to take a break right now for you guys to do a little reading on and to retake the self-assessment. So on Moodle, and hopefully it's going to open on this page. And of course it did not, so now I have to run around my screen. Put it on the right page. I meant to make sure I was opening on the wrong one before you guys came in. Okay, or the right one. So on the Moodle book in our class, for chapter 3. I need to take away my grades so it doesn't look like I'm failing my own class here. If I go down to the book down here on PC Power, at this point we should have already read, at least once, the form factor section, okay? I want to take a break right now and have you read through the power section. We've already talked about alternating current versus direct current, so hopefully for at least 3 of you that's a review. And I want you to read the one on how these two on how PC power supplies work. And then I don't want you to look at the math part. We're going to talk about how to do the math after you've read those, okay? So these aren't overly long articles as you read those. In fact, this one's really short and has a little video in there. I mean, you can see that's how short it is. This is a nice little video on AC/DC. This is really a continuation of the same article. This is the beginning on PC power, and then this is the rest on how power supply works. And it specifically talks about wattage. And then we're going to go talk about how to calculate that wattage next after you guys are done reading it. So we're going to take a 25-minute break to give you time to read that. If you're done before that, just tell me and we'll continue on from there. I don't want to sit here while you guys are reading. But I want you to take a break to read that, and I want you to redo the self-assessment for Chapter 3. If you haven't already done that, do it for the first time. And then we'll continue on with our discussion after that. Okay, so F9 on. Did I get it? I didn't get it. I got it backwards. Okay, so just so you know what I'm doing. So the last thing we're going to talk about today, if we get time to it, is actually calculating. The next was talking about power supply problems, since we're talking about power. And I had you read about power in general and then how power supplies work. So there's some things that can cause problems with electrical components, and we've got some stuff that we can do to protect against it. So that's what we're kind of talking about next. Electromagnetic interference is one of the things that can cause problems, and it's one of the things that you guys don't have to deal with very often anymore. It's caused by the electrical field that's produced from electricity flowing. Anytime electricity is flowing through things, there's an electrical field that's produced. And we can buy really crummy cables, or we can buy really good cables when it comes to cabling. And let me tell you, I've had a good smattering of both in the school as I've done stuff. And I've kind of learned my lesson as I've gone, the difference between a good cable and a bad cable. If we use a bad cable that's not shielded, we could have a lot of things cause problems for us. For instance, the first LCD projectors that I put in the district, I bought the cheapest cable I could find because I was trying to do as many projectors as I could at the same time. I had a limited budget. I don't even have any of those cables anymore. But I bought these cables off Amazon or wherever I got them at the time that I didn't realize how much the shielding would affect things. It's not as big of an effect now because we have better lights than we did then. But when I first got here and started hanging projectors in 2005, we had the old ballast lights up, and they caused a lot of EMI interference. And when we had cheap cables running across the lights, and so the cables go up from the teacher's computer, and they always cross at least one light, if not more, before they get to the projector, then we would get projectors that we'd go and we'd look and they'd have like the image, you'd see 2 or 3 images, right? It's like it was over top of each other and it would be all fuzzy and be like, the projector's bad. And we pull down the projector and put up a new projector and the projector would look exactly the same. And then we pull the cable and we would try a new cable, but if we ran it the exact same spot right across the back of the lights, we'd end up with the same thing. If you get better cables, it offers partial control. The best thing you can do is not put things really close. So when we'd end up going over, we'd end up going up through the rafters over the cables, over the lights, so they wouldn't be laying on right top of them and then come down the projector, and it would solve a lot of the problem. Power supplies, one of the other reasons they're in metal cases is to shield that EMI. These cause the most amount of EMI in our computer. Okay? And if they were in a plastic case, which we wouldn't do because they get so hot, but if they were in a plastic case, you'd have no shielding between them. So those things can cause all kinds of weird problems that don't make any sense. And then when you move things away from other things, all of a sudden they work. If you have computers laying right next to each other in a row running, they can cause EMI with each other and have weird things happen. Okay? Which is why a metal case is always better on a computer, because it shields both the inside components from EMI that's outside and vice versa. You can take an AM radio and put it off frequency, where you get the static, and put it near things, and all of a sudden the static gets much louder, and that's a detector of EMI. Okay, so that's one thing that I didn't even realize would cause such a problem with weird things like our cabling, and it can cause the same thing with like our network cables. If we've got a network cable bundle running, those cables aren't really putting out enough electrical current to interfere with each other. But if all of a sudden the new electricians run a big, huge wire right over top of them and lay it right on top of it, all of a sudden we have wires that don't work. And we've had that happen this summer when they were rewiring stuff, that they weren't keeping their own stuff shielded. They're putting it right up against a data cable, and then it doesn't work anymore. And I have to run a data cable because there's no slack in those to move them up there. The only thing I can do is rerun a new cable. So EMI can cause us problems, and that's one of the things. I should have made a chapter on those. Yeah.
So like when you put two phones together and it makes that like real loud sound.
That's EMI with each other. That's exactly what it is.
Okay.
So. Okay, so our next objective is to learn what power problems can affect PCs and how to protect against them. And I don't know why I didn't have that before the last slide. In fact, let me redo that. I don't know why I didn't have those. It should have been like that because we just learned about one of them. The other power conditions are these power conditions right here, and this is definitely on the test. And these are the three most prevalent power conditions, especially the last two that happen to us all the time. Okay? Theoretically, if everything was perfect in the world, then when we said we were getting 110 volts and 60 hertz, which if you remember, that's what we get out of our plug, we get 110 volts, and it's alternated at 60 hertz or 60 cycles per second. If all was perfect, it would stay right there at 110 all the time. It would always be there. Things are not perfect, and our power is not perfect, and even my drawing was not that perfect because it goes a little lower. It doesn't happen. We get fluctuations in our power plugs all the time. So these are the different kinds of power things that can happen. So a brownout is, first of all, it's a momentary reduction in voltage. Okay, so we're going along and we're at 100, cycling at 110, and all of a sudden it drops down. That's a brownout. Okay, we used to have them here all the time. When I first got here to trail, we would have brownouts probably 5 or 6 times a week, where the lights would get dim because, by the way, brownouts a momentary reduction. We still have power. Doesn't all go away. But there are some things that have to have power in the correct band to work. And when all of a sudden you have less power, they don't work at all. Okay? An incandescent light bulb does not care if there's a brownout. It just gets a little bit dimmer. Right? It just gets a little bit dimmer. But a fluorescent light bulb, if it goes below the threshold power that it needs, doesn't work at all. So we would have the lights get a little dim, and then they start going on and off because we were just at that threshold, and if we get too low, then the lights are out altogether. Okay? PCs don't like brownouts. If they don't have the right amount of power, they just shut down. Okay? They just turn off. It has to have a specific amount of power. So brownouts are momentary reduction. When I say momentary, I mean it's just like things going up and down. You might have it at your house all the time. I have it at my house. We get brownouts on our power grid where all of a sudden you hear things go off. It still happens every once in a while. You might hear my backup power supply over there go beep, beep, and it just flashes for a second. It wasn't enough that the lights even changed. because we have better lights now than we did then. And they use much less power than what we had when we first got here. But my backup power supply doesn't want it to get below at all. So as soon as there's a little change that we might not see, you hear that beep, that means there was a little brownout that happened, that it picked up the power for my PC. Okay, so momentary reduction. Spikes and surges are the exact opposite. They're momentary increases. Increases in voltage. Okay. Now, they can be huge. They don't have to be small. If your house gets hit by lightning, it's had a surge or a spike, it can be very large. But they can also be very small. Small enough that we don't notice on a daily basis. And one of the reasons that we have power supplies go bad is because there's little tiny brownouts and spikes or surges happening all the time because our power's not perfect. In fact, in Eaton, where my wife used to have a shop downtown, it was bad enough that we never saw the lights change or anything like that. But I had a portable telephone. We went through 3 of them in 2 weeks. They kept burning up. And I take it back to Walmart, and they give me another one. I bring it in, burn up. Take it back to Walmart, and then I was like, there's something wrong with your power. And I plugged in a surge suppressor, and that one worked forever. Okay? Because we were getting little momentary spikes, enough that we didn't really notice, but enough that it was burning out her power supply. And in that case, it was a little plug-in one like this, not really like this, but little plug-in adapter. But that happens to these all the time, that over time they wear out from absorbing those little small spikes and surges that happen all the time. Okay? So on electrical components, that can obviously be bad, and we're going to talk about the things that we can get to solve this. Blackouts are complete loss of power. Okay, voltage goes to 0. There's no power at all coming through. Okay, that's what a blackout is. You guys have all had, I'm sure, at some point in your life where your house lost power because a tree fell on the limb, somebody hit a power pole, whatever. But a blackout is a complete loss of power. Those are all power conditions that adversely affect computers, right? Trail 2 all of a sudden lost power, in your case Trail 4, and you lost all your network drives and you were in the middle of saving a paper, you would be unhappy, right? If I had it open and I just wrote a whole paper and I hit save and the network went out right then, where'd it go? It might be gone, okay? So we want to protect ourselves against brownouts, spike surges, and blackouts. We need to protect ourselves against all those things. And we have different things that we can put in place to help protect ourselves against those, okay? So we have different things that we've got, okay? So we're going to go and we're going to talk about all these. I think I have a different slide on all of them, okay? So the first one is called a surge suppressor, okay? A surge suppressor or a power suppressor does those things. I'm trying to find one sitting here. I'm going to grab one out of the closet next door. Okay, here's my little tub of power strippy stuff in the closet, okay? Some of these are surge suppressors, okay? Some of them are. This is not a surge suppressor. It's just a power strip. This just turns it on and off, okay? That's all this does. This does nothing at all to protect against power. And many times when I say, hey, you need a surge suppressor, people go and buy one of these because it's $5. But all it does is make sure everything plugged into here breaks at the same time. Okay? Does not protect. A power strip is not the same thing. This, and let me see if I got another one in here. Nope, I gotta look. I actually have to look at the back to make sure before I go and say something that's untrue. But I know this one is. Okay, so I'll pull out this one, although it's probably no good anymore. But this one is a surge suppressor. And on most surge suppressors, it has a light on it that tells you whether it's working and protecting you or not. So if I plug this one in and that light doesn't come on green, it's doing nothing, okay? And if I was to take the ground off this and plug it in, that would not be green. Surge suppressors don't work without a ground, okay? What they do is they shunt to absorb surges that come in through this. And what they do is they basically, anything that's above their threshold, it just clips it to ground. And all that extra voltage just goes to ground. It just goes away to ground. But if there's no ground, it can't go away to ground, okay? So some of them block the surges, some of them absorb the surges, but the big thing is they're measured by a clamping voltage or the amount of energy it can absorb, okay? So it can only do so much, and it sends that extra power to ground, and it protects it from momentary surges and spikes. And if I go and look, and I'm going to go onto Amazon and look at surge suppressors, and I'm not saying you should buy from Amazon, it's just easy to find stuff. And we're a prime district, so, and I'm spelling that so terribly, but it knew what I wanted. Okay, so I'm going to look at surge suppressors. So when I look at surge suppressors, number one, they're not overly expensive. And I don't even know if this is a surge suppressor. I want to look and see what this actually opens up as, because I feel like it's misleading what it's saying. Oh, it is. Okay. So whenever we see a surge suppressor, it says basically a rating in joules of how much it can suppress. And the bigger this number is, the more it can protect you from. Okay? Whenever I buy one for my house, and this is a good example, I want one that has insurance. In other words, what this is saying is that it will pay for up to $50,000 worth of damaged equipment that's plugged into this if it happens and doesn't protect your stuff. Okay? Number one, it only works if there's a ground. But this is 1038. Would be great if I could go back in time and have one of these with my 30 CD carousel that doesn't work anymore. Okay? Yeah, it was before, when CDs were big. It was awesome. Hold 300 CDs in it. You had to plug in a keyboard in, and you could say exactly what each one was, and I could go and hit James Taylor, and it would go and make a mix of James Taylors off the CDs, and the CDs would go. It was really nice. They still have it just because it's so cool and look like stringing on what's in the CD spinner. Anyway, I had a surge protector on it, and it was plugged in to a 3-prong outlet, just like I teach you guys to do. But the guy who wired up the outlet before I moved in put in a 3-prong outlet with 2 wires on it. There's no ground behind that outlet. And when it fried after an electrical storm, I'm like, what is going on? And I literally pulled the outlet out, and it's got 2 of the old clothy looking, I don't know what they are, they're not rubber covered, wires just connected up to a brand new looking outlet. I was so mad, which is when I started rewiring my house, an old 1920s farmhouse. So if you go and spend your 1038 on this, but don't have a grounded outlet, it does nothing. Okay. So what this is doing, it's protecting everything plugged into it up to 790 joules. How do they know whether you went over the joules? I have no idea. Okay. Mrs. Eels, Mr. Eels' wife, asked me one time, about this, and I said, get one, but save the packaging and the receipt, because they will not honor it unless you do. And she did, and they had an electrical storm, and she lost her whole computer, and they bought her a way better computer because her computer was really old, so she got a free upgrade at no cost at all. Okay? It wasn't the best computer you could buy, but it was way better than what they owned. So they're all rated like that, and if we were to go through here, you'll see that some of these probably are really low in the joules, but a lot of times, let's see what this one has. It says, so this is only 600 joules. But if you were going to college and you just wanted to be able to plug your computer in, it's going through that whole building, that's probably fine. Look, you can plug your phone in and everything to that one as well. I would highly, highly recommend making sure that you've got things plugged into something like that. We have, by the way, nothing on all the teachers' PCs in the high school. We just bought, we already put these on every elementary and middle school, but we didn't get them in time because they didn't have enough in stock to do the high school teachers, so they're all sitting in a box over there, and I've got to do it because there's nothing protecting any of them in the high school, which is bad, right? And during the last electrical storm, we even had the projectors go out, and we got to figure out how we need to get a little, like one plug one, and go in the ceiling for every projector and put something in there, because that's actually more expensive than the computers, because I get all the computers for free from base, and I have to pay for all this. But the plug is way up in the ceiling, and it's a pain in the rear to get to. So anyway, there's another one, and this one, let's see, this one has $20,000, protects up to 1,500 joules, has 2 LEDs to let you know that one says grounded. I don't know what the other one says. Grounded and protected. There's 2 lights there to let you know that the thing's working. If the electronics burn out inside it that's running the protection, the protected light will go out. It'll still work as a plug. But if that light's not on, I know that my stuff isn't protected anymore. So that's a surge suppressor. And if we went down here, there's all kinds of looking surge suppressors. They have ones that you can plug your phone into and your Ethernet into. Wow, that one's pretty awesome. How many? Does it have 6 USB plugs? Wow, that's a lot of USB plugs in there. I wonder what the amperage is on the USB plugs. Anyways, you can see there's tons of different options on surge suppressors, so you can plug all your stuff in, and they're in varying costs, but you can see that I can spend $10 and protect myself from $50,000 worth of stuff. No reason not to have that in your house, protecting your valuable equipment, because it's not just about electrical storms. It's about those little tiny things that we don't even know that are happening that take things out. Okay, so this only protects against surges and spikes. Surge suppressors only protect against surges and spikes. So there's going to be a matching question on the test, and it's going to have all 3 things. It's going to have brownout, it's going to have blackout, and it's going to have surges, and it's going to have the 3 different things that I'm about to talk about. This is the one that goes against surges and spikes because it only protects against surges and spikes. Power conditioners are made to protect against brownouts and surges and spikes. Okay? They're not full coverage for power. It's like kind of like a battery in your building. It's usually only for industrial places, so the power can't go up and down, but it provides continuous voltage during brownouts, and it also provides some protection, not as much as a surge suppressor, but it provides some protection against spikes. Okay, a power conditioner regulates power. It tries to keep it perfectly on that 110, 60 hertz spectrum, and it protects a little bit for increases and it protects a little bit for decreases. Okay, it conditions your power to be better. But this is very rare. It has to be in a really good building that they built it to condition the power when it comes in. Okay, so power conditioners is going to be the one that matches up against brownouts, because that's the one this one's really specific for. The last one, and the one that we have in our closets, and they're kind of expensive, are called uninterruptible power supplies. You'll hear me call them UPSs, or I will frequently say they're UPS. Okay, it's all the same thing. They're uninterruptible power supplies. They provide backup power when all AC power fails. They've got big batteries in them, and they're very, very heavy, and I hate moving them and installing them. It takes 2 people for a nice UPS to be installed. Okay, it filters the AC power. It conditions the line for brownouts and spikes. UPS does it all. Okay, all the power continually goes through a computer and a battery before it comes out of the plugs. Okay, so it protects against very high spikes, okay, that could damage equipment. It keeps things running if all power goes out. I've got 2 over there. I've got 1 running each one of my PCs to protect my stuff, so that if I'm doing something, there's one. I think there's one. There's one back behind here. Here, I'll slide it out if I can. This is one of our old closet. If it sounds like I'm groaning, I am. Okay. If you want to come over and try to lift it, it's very heavy, okay? Because it's filled with batteries. And on this, I've got a little button on there I can push. It says what the current voltage is, what the current hertz is, the power coming in. It will say, where's that? What my percent of load is. and it'll tell me how long, if I get to it, how long the thing will run. It's saying this will keep running for 99 minutes, whatever is plugged into it, which doesn't seem to be anything at this point because it said it was 0% load. I don't know I haven't looked at the other side of it. Okay. But in all of our closets, we have those hung up on racks that run all of our Wi-Fi, run our video cameras, run our switches in the background, run all the servers. And honestly, we've got so many of them and so much stuff on them. We only get around 30 minutes of everything running. After 30 minutes, some of the overloaded ones start to drop off, and the Wi-Fi will keep, if we lost all the power right now and you guys are online, you guys will be able to save your stuff to your drive. You'll be able to go ahead and surf for a little while, and then eventually you'll see the light in the Wi-Fi access points go out because that's using a lot of power to run all of the Wi-Fi. But, so, UPS does it all. They can be very expensive. They have cheap ones, but the cheap ones are cheap. They don't work. I've tried them. The little cheap ones don't last at all. I used to have one up here. I think I must have put that one away. Okay, so they protect against spikes and brownouts and total blackouts is what UPSs do for us. They make ones that just sit beside your computer. All the ones that we've got are like that one, which is really made to be mounted in a rack. But you can also obviously stand them up. They have feet that come with them to stand them up beside them. I'm going to go to look at UPSs. Okay, the last part of UPSs, most of them are smart anymore, meaning that you can connect them up to your PC through a USB cable. In the case of ours, they just go through the network, and they tell the computers that have the right software installed how much power is left. So our servers can go ahead and say, the UPS will report that I've only got 5% of my power left, and the servers will go, I'm shut down now. And they'll just turn themselves off, as opposed to just having the power yanked out of the back. Okay? If you have one hooked up to your computer, you can have a USB cable running right into it. You have to install special software to make it run, and it'll monitor that, and it'll automatically shut down at some point when the blackout happens. Okay? So that's what smart ones do. I'll be honest, I have very little of the software installed in the district because not only do we have battery backups, we have a building generator, and the whole point of this rewire project was to put all my UPSs on the generator, so if we lost power, the generator would restore power to those closets within 5 minutes, so we never lose power. So why waste time setting them all up to a shutdown when theoretically they should never shut down? Although I should have. Okay, and they also have ways to make it remote startup through a phone line so that I could call that number and it would turn it back on. So smart ones do all kinds of cool stuff if that's what you get. Okay. UPSs can cost a lot of money. You have to think about that. What are you going to put on it? And I'll show you how they're rated, but they're rated for, you'll see a VA, a volt amp, and we know volts times amps equals watts, so it's a volt amp or a wattage output rating. And it will also tell you things like how much it will condition the lines. And I really want to pay attention to, is there a warranty and what kind of guarantee does it have on it? Because if I'm going to spend a lot of money on it, I'd like it to be a nice product. And let's look at a couple UPSs. This is just a list of different manufacturers. We'll go ahead and go back to Amazon here, and I'll show you the spectrum of costs. I'm going to go to the highest cost first just to show you that the cost can be very high. $32,000, okay? We don't have any of that, but I don't even know what that is. 10 pack for $20,000, and why is it even showing up in this? I don't know. So, but you can see that why is that even on there? These are UPSs, there we go. There's a nice $10,000 one. I don't even know. They're hoping somebody buys that. So you can see that they can be very, very expensive. Now, in all reality, we've never bought one that's over about $600. In fact, I'm going to put in. You can see these are replacement batteries from when the batteries go out, because they only last about 3 years, and then you have to replace them. So you can buy the batteries and just put them in yourself. I don't want batteries. Let's see. I'm going to say six outlets and see what we start getting. Here's some cheap small ones. We've tried those for some of the staff members' PCs. I will be honest. If they can keep the computer on at all, it's a wonder. Most of them are so small and so underpowered. So I don't recommend getting a UPS for your home. I mean, it's a lot of money. I definitely think you get a surge suppressor, but here's a good example, okay? So this one is a 550 volt amps UPS, which I just opened a new window. It is, how much money? Where'd it go? Didn't we see the money there for a second? I guess we didn't. It says it's $25, okay? And like I said, this 550, that's a really, really, really low number. The ones we have are 2,500, okay, in our closets to keep things running. This may not even keep your computer on, and I bought actually this one thinking that it would keep the computers running. You get about 5 minutes if it stays on. My computer at home won't stay on at all with that. I've got 3 hard drives, or I've got a really good video card. I have a lot of stuff connected to my computer at home. I had one of those, and when the power went out, the thing just went bonk. Didn't have enough power going through it to even keep the thing running. I should have known that. It says 255 watts, and I have an 850 watt power supply in my computer. That number is a little bigger than 255, so I should have known that it wasn't going to keep running. Are we about ready to run out of time? Yes, we are. Okay, well that's good, because this was the last thing we're going to do. In next class, we're going to do the power calculations, since that's where we got to. But if I go through these other upses, let me go back, battery back up, and see if I can get. Go back again. I want batteries. I want the actual dealio. See if I can find. And the one we have, I think, are Cyber Powers or Trip Lights. Let's see. And we have big rack-mounted ones, which are bigger, like that, okay? Actually, that might be ours. That might be that one right there, as a matter of fact. So on this one, you can see the volt amp rating up here. So it has the volt amp and the wattage. It's got 8 outlets. 2U is the size of the rack that will go in. And you can see it comes with feet, and it comes with the rack mount thing. That's a nice one for $400. But really, when you look at these other ones, you really have to look at how much you're going to have connected to it and how long you need it to last. If you're doing something critical at home, that might be a really good idea. For instance, I've got a little tiny one that runs my router because we have internet phone and I have Magic Jack. So I got a little one on that because it doesn't use much power, and if the power goes out, I don't lose the phone. So there's a point where I might have an ups. But on my computer at home, am I doing anything that's that grossly important that if the power goes out, well, hopefully I've already turned it off before electrical strike, and I've got a surge suppressor on it. So in conclusion, those are the things that we've got that we can use to protect ourselves against the different power things, and I think that is the end of the thing. So next class, we're going to talk about power supplies, how to calculate what we need. I'm going to talk about the power supply project and is it a demo? We've got 2 more classes before the chapter 2. Okay?